Java.
Yes, Java.
Yeah.
Java.
Yes. Yeah, you're right. It's Java, right? So it's Java. So again, I cannot say it enough, right? So if you go to Google, Bank of America, this is the code that you will see. Of course, if they have written their website in Java, yeah, this is the code. But in C#.NET, it's kind of similar, same structure, same kind of flow. And it's pretty similar. If you know one, then you can automatically understand the other, right? So now, if you look at it, right? So, um, do you guys know the program execution begins from where
Main.
in Java? You have I don't know 20-30 lines of code, right? You can see that, right? Do you know where to start reading the code?
Main function.
Yep, that's absolutely right. That's absolutely right. So the main function. So again, I always put it into the perspective of your job, right? So what you will be doing. This is the real case, right? Real life, and real work environment, right? So you're part of cybersecurity, and you will be assigned to one of the development projects, not by you, but the development project where developers are building the project, right? So the software developers are writing the code day in, day out. That's their job, and they have these daily stand-up meetings, right? It is a agile methodology. Every day in the morning, first thing in the morning, 15-20 minutes, right? You have a stand-up call. That's agile methodology. So in that stand-up call, so you will be assigned to that project. So then on the conference call, whatever the call it is, you will have developers, joining the call. You will have the project manager, Scrum Master, right? The guy, they will also be part of it, and there will be a tester, maybe a project manager, right? So these are all different departments, right? Tester is from QA department. The developer, whoever the developer that is writing the code is from software development team, right? Dev team. And then the project manager, Scrum Master from project PMO, project management office. So and then business sponsor, the sponsor of this project, the business guy, right? So we head of the business, from the user's perspective, right? So he will also be on the call. And then for the same project, you will be assigned as well, and then you will be representing cybersecurity. All right, so that's you. So all these different groups, they meet every day, right? So then in those meetings, this developer, right? The developer that is writing or building the app, I don't know, it's a Facebook app, let's say, imagine, right? Just as an example, and is writing Facebook, newer version of Facebook, right? Then the developer, they will ask you, because you're on the call, right? So the call. So, hey, we are. This is the flow of the application. It is a online application, and customers are connecting. They visit this link, and this is how they navigate. They log in, and they go this link, this page, and this button, and whatever, right? They explain the flow. Then they will ask you, so now they will turn it over to you and say, okay, so now customers are connecting, and they are submitting or uploading some data, their date of birth, maybe their social security number, maybe their credit card number, whatever, right? Or their bank statements, whatever. So they are uploading through this platform or through this website. Then you will be asked to advise how this developer has to write the code or write the source code in a way to receive data from the customers in a secure manner, in a secure transmission, right? So that's the question they will ask you, right? Of course, you're a cybersecurity engineer, so you will say something. Yeah, you should be using HTTPS protocol, TLS version 1.3, whatever, right? So you just say, right? You just say what you have to say. Then the developers say, oh yeah, that's no brainer. We are doing it. Yes, of course. We follow TLS 1.3. We the customer data, they encrypt it and we use some algorithms and we decrypt it when we receive the data, the routine dialogues, right? So they will say. So now, then they will seek your approval. Okay, so, they said it, right? So the way how they develop and they encrypt, decrypt, they will explain, right? Then they say, oh yeah, so we follow that, so can we get an approval from you? Because cybersecurity has to approve it. Otherwise, they cannot release that code or that new feature of Facebook into production. You are the signing authority, right? Then what would you do? What would you do? You will just take their word granted? Oh yeah, I heard all good things about how the development team is developing. Oh, I'm so super happy. So yeah, here is the approval. All you just go ahead. Do you do that? I mean, do you do that? And then you sign up and you move on. Do you do that, or do you ask for anything? Do you need anything else to validate what they have said? So it's a question to you guys. So how would you handle it? This is the real work scenario. I'm giving it to you. I mean, trust me, this is what's going to happen. You will be put on the spot because developers, they're in a rush. They don't want any extra work. They always need your approval. So one less thing to worry about. That's what they're going to ask you. So what is your reaction? All right, so I presented the real scenario just in front of you guys. All right, so now go ahead. How would you respond? What would you do in this case? Anyone, go ahead, guys. Feel free. I mean, any answer is a good answer.
So we need to look into the business requirements to validate what they have said or what have the security implementations have been mentioned. We need to follow the requirements first to match the design document.
Okay, so that's a good start. So what you said is, yeah, so look at the requirements, whether they are satisfying the requirements. I know you mentioned about design document. Yes, of course, that needs to be very validated as well. But let's be specific, right? So I mean, let's say that's all done. That's all done, right? So let's be specific in a way that the data security. So we're talking about the developer said that, oh yeah, all my customers, when they upload their personal data, we receive it in a secure manner. All encryption data security standards are being followed. And so what would you do? What would you see? I want to be very specific, not way generic answers, right? Yeah. So what would you ask? How do you check?
We will do source code analysis.
Okay, good. Okay, so go on. So how would you do it? What would you ask? How would you do? And
we will get a code like a file, and we will check it with the commercial tool check marks 45 to identify the vulnerability and eliminate a false positives.
Okay. Yes.
Okay. Okay, $40. I feel this number 2.
Guys, if you can mute. Okay. Okay, good. So that's good. So yeah, I heard about the source code review, and so that's a good thing. That's a yeah, you're in the right direction. So anything else? Anything else to be added? Okay, cool. So yeah, that is right. So that's where you will be. You have to. You cannot just take their word as granted, right? So you need to ask them. Sure, whatever the mechanisms you're following to receive customer data in a secure manner, fantastic. But now, can you provide me A, B, and C items, right? So those A, B, and C items are the source code. Yeah, I need the dump of the code, code base, right? Code base. I need a copy of that code dump, and then two things: whether you can scan it, you can scan it. I mean, there are scanning tools. I don't know how many of you guys have attended the previous week's classes, but we looked at Qualys, right? We did Qualys a few weeks ago. So that Qualys can be leveraged to conduct this analysis, and at the same time, there are a bunch of other tools as well, like that. For instance, as someone said, so check marks, AppScan, Fortify. There are some tools available to scan the code. So meaning, scanning in the sense, now you see, right? So you see the code here. So it reads the code line by line. See the private, public, message, try. So it reads line by line, and then it will detect if the code has any known security vulnerabilities or weaknesses or bugs. It does that, right? The tool has that intelligence. So, and then if it did find anything, then it will report that as an issue. A report of all the bugs, right? So it will generate a report, and then you will have to validate. Sometimes the report it reports false positives. They are not really true, right? So in those cases, so you have to clean up the report and make sure only the legitimate findings are there in the report. And then you go back to the same developer who said they're doing encryption, all those things, right? So just go back to them and then say, yeah, these are the flaws in your code. Can you fix it? And then you need to give them the guidance. What is that flaw, and then what is the recommendation to fix it? That solution also you have to give. Of course, those tools will help you. Tools, when you use check marks and all, there is a knowledge base, so you can clearly see what the bug is, and what is the recommendation to fix that bug. So everything is there. You just have to rehash it. You just in Word, you just like summary, right? So if you read it, you summarize it to the developer, and if they agree, then they will go ahead and fix those bugs. Then you sign off, right? That is the right way of, right? So that's what it. So now, yeah, coming back to this, there are instances where these tools cannot help. Yeah, I mean, tool is a tool, right? It's a machine. It's a program, right? If the tool, well, I know AI and all, but in general, the tool cannot think like a human, right? So situational based, right? Unless you program to do so. But again, even if the program has any loopholes, then of course it will fail, right? So that's why you cannot completely dependent upon the tool and then tools review. So you have to manually review.
Yes,
so that's. Go ahead, guys. Someone has any question? Okay. So I would say more than the tool, you have to maybe 50-50, maybe 46%, 40-60%, maybe 40% tool help, and then 60% you. human, manual, right? So that is, or maybe 50-50 would do, but you cannot 100%, even not even 70-80, right? So you cannot rely upon the tool to help you. No. So you have to do this manually, because as I said, so tool doesn't have all the human brain, right? So that's where you will have to open up the code like this and review line by line, and then see if it makes sense, or if any enhancements need to be made, any flaws, right? So that's what we're going to do today, right? So so it's a real time exposure experience that you're going to get. Tool is pretty straightforward, guys. I mean, you just plug and play. You just feed this code, right? And just like how you feed this code to an AI, ChatGPT, and ChatGPT will summarize it for you, just like, right? So that's pretty easy, but the results are not really accurate, right? So that's why. So let's go through this manually, right? And then see if what flaws or what weaknesses we can identify. So yeah, so as you said, so these Java programs, the execution begins from the main method. So as you can see, this is the main method, right? This is the main method. So what am I doing? Here is this is the class A. So the purpose of this program, the source code is to encrypt your credit card number. Yeah. So imagine you're on Amazon, and then you added an item to the shopping cart, and then you are checking out, right? You are checking out, and you are on that page where you will be populating the page with your credit card number, expiration, and all such details, right? So and then you check out, right? So you press the checkout button or submit button. So when you submit, then whatever you filled out on the page will be posted to the website, the backend, right? So the Amazon receives your credit card number and all, farm details. Okay, so then once it receives your details, then it validates, right? Yeah, it receives and it validates. If the credit card is good, then the transaction will go through, right? And then once the transaction is done, what Amazon does is it will save. It will store or save the transaction details, isn't it? Like, if you go to order history, right, you see that, what did you buy, how much quantity, So, and then if you also check, the box where, save my credit card for future purchases, right? There's a check box, right? So if you turn that on, then Amazon will also save your credit card number in the backend database. So this way, for your future purchases, you don't need to take out your wallet and and then get the credit card out and then start typing and all that. So it's convenience, right? So Amazon has it already on their database, so it will reuse it. So now, here is the thing, right? So when you want Amazon to store your credit card data, then Amazon cannot and should not, right? So Amazon cannot save or store your credit card number in plain text. Your numbers, right? Credit card number, 1 to whatever the number. So it cannot and will not store in the same plain text numbers. So it has to encrypt it. It has to, because of the same reasons, right? Remember we talked about for the past week or so, someone can steal, right? Someone, a database administrator, your friend working for Amazon can steal, right? They have access to this database where the credit card numbers are stored. So for obvious reasons, they don't store your credit card number as is. They have to encrypt it. So that's when they choose the algorithm, right? So AE is symmetric or asymmetric, and we talked about it at length last week. So let's say if they choose to encrypt using symmetric, then the algorithm that we discussed was AES, right? AES, Advanced Encryption Standard. So AES 256 key size. That's the industry best practice, and pretty much every company is using the same size, AES 256. Symmetric algorithm, meaning same key will be used for both encryption and decryption. All right, so let's assume Amazon has chosen symmetric algorithm, AES 256, to encrypt your credit card number. Here is the program. This is what Amazon is doing today. How Amazon is encrypting your credit card? I mean, if you want them to save it, this is what it is. So now, so main method, right? So where is main method? Let's go through the main. So here is the main function or main method. And you can see this curly bracket is the open curly bracket. That means it's a block. It's a method beginning, right? So it represents the block of code that belongs to this main method. So there is an open, and then if you see here, the closing. So between see the open, this is the main, open and close. So there's a block of code. See, this is the block of code, right? So that will be executed. That's how it begins, right? So now let's go through it. So here I declared secret key, right? Secret key. So this is my secret key. This is my secret key. You can have it. So say Venkat secret key for his website. I don't know his website. I don't know. Movietickets.com, right? That's his website, right? So Venkat secret key for movieticket.com. So that's, again, this is secret. I mean, this is, I know you all can see, but this is supposed to be a secret key. So as you know, for symmetric algorithm, there is a secret key, right? So it's a common secret key, and this is my secret key. All right. So and the next is credit card number. So this is the credit card number. Imagine that customers are uploading, because customers are submitting, right, for checkout purpose, checkout on the checkout page. Because I don't have a live application, so that's why I'm hard coding it here. But in reality, this number is not hard coded. It comes from the browser, right? User browser. Like same thing. Imagine checkout page, right? So you populate it, and this is the number. So this is the credit card number, and this is the secret key for my website. And so those two I declared are hard coded. And then see here, this is dot encrypted. So this is another method I'm calling. This is a calling, right? So I'm calling this method by passing these two variables. See, credit card number, which is credit card number. See here, credit card number, this and this. So I'm passing my credit card number 2467 along with the secret key. Secret key is what? Venkat secret key for movietickets.com. So I'm passing, and then I'm calling this method. So there is an encrypt method somewhere in the code. So let's go and find it. So encrypt is taking two arguments. See, these are the two credit card number, comma, secret are arguments. So let's go up and see there should be encrypt. See here the encrypt method. So I'm calling this method. So whenever I call the block of code, see here, this is the block of code. This is the block of code, right? So until here, right? This is the block of code that will be executed. So what am I doing here? Again, two variables, string to encrypt and secret, which is what we passed, right? What did we pass? See here, if you look at it, what did we pass? Credit card number and secret key, both we passed. And that's what you have. So this is the credit card number and this is the secret. And credit card number, as you can see, we hard coded, and secret key is Venkat secret key. So it takes those two, and then see here, set key. It's like a chain, guys. Okay, so the main method is calling encrypt method, and encrypt method is calling another method called set key. Yeah, it's like a loop. Well, yeah, it's more of a nested, right? It's like a nested method calling. Yeah, it's a nested. One buried under the other, right? So that's what it is. So main method, inside the main method, we have encrypt method. Inside the encrypt method, we have set key method. Yeah, it's like buried inside, right? So set key, so there should be an implementation for set key as well. So if you go and look at it, set key, where is the set key? Set key. Yeah, see here, this is the set key, right? So the set key, again, the open and close. So that's the implementation. So here what's happening, right? So what is this my key? Let me ask you this. What is the value of my key here? This one. Can anyone guess? What's inside my key?
It's
a secret key, Venkat.
Yep, that's
.com.
absolutely right. So yeah, that is being passed, right? So that is being passed. So if you look at it, right? So set key, you're passing secret. What is secret? It is the Venkat secret movie tickets. So where is that? Yeah, this one. So this is Venkat secret key for movietickets.com. So I'm taking the English letters, Venkat secret key, and I'm doing, see here, see my key, right? So my key has, just write a pseudocode so you understand. So my key, right, has the value, I think Venkat secret key for movietickets.com, right? So that's the value, right? So this is plain English, right? So it is taking this key, and then see, this is the key, right? This is the Venkat, and it is extracting. Well, I said it's like encoding into UTF-8. Now UTF-8 is like universal, the Unicode text format, something like that, right? So it's like it's converting. Where is this? Yeah, so it is this English, right? Characters are getting encoded using UTF-8. Yeah, it's encoding, right? Encoding, it transforms from one format to another format. I'm doing that, so I'm converting it, right? So that's what it does. So the transform UTF-8 transformed value is now stored in key. See here, you're assigning left to right. You did the transformation and then you assign that to key. And then there is something else here. So SHA-1, what the heck is this SHA-1? I mean, what is SHA-1? I mean, we learned this last week, right? What is SHA-1? Anyone? What is SHA-1?
Hashing algorithm.
Yep, it's a hashing algorithm, right? So this UTF-8, let's imagine this is like a crappy UTF-8 format. Let's imagine it looks like this, right? This is UTF-8 converted Venkat secret key. Uh-oh. Okay. Right? It got converted like this. Let me just bold it so we can differentiate. Maybe red. Yeah. Oh. Red color. So, okay. Right. So now I'm initiating the hashing, and then see this key. Oh yeah, so this key, which is the UTF-8 converted encoded text, and then I'm transforming it to SHA. What is SHA? SHA? SHA is coming from SHA-1 hashing, right? You see the connection. The key is the UTF-8, and I'm passing. It's like a feeding, right? You feed one output into the input of another channel. That's what I'm doing. So I'm feeding the UTF-8 Venkat secret key into hashing algorithm. See the SHA dot, right? Then this key. Now, what is the value of key here? What is the value of key here? Anyone can guess? What is the value of key? Is it this?
No.
After SHA-1? No. So you are again converting to something else like this, right? You're converting, you're hashing it. This is the hash. You're hashing it. You're converting into this, right? And then is array copy 18 16 right. They're choosing the length of 16, so they are again taking that an array of 16 bit, so they're doing, right? So 16 characters, right? So 16 characters, right? So the code is doing, again, it is extracting, it's actually converting, right? So into 16 character array, it is converting, right? So this is another transformation. It went to 16, and then here you look at it, the AES key, right? See that the same key, the array, the 16 character array, is now passed into AES. See this 16 character array and AES, and then this new secret key spec. This is another transformation. Right? So again, this is another AES transformation. So now the resultant of the text is again something else. Who knows, right? This is some garbage. Some garbage text is what is being produced. So at the end, where am I? Yeah, this is the end of it. Yeah, this is the new one. So this is the end of it, right? So at the end, I mean, this is an exception, so this is not a transformation. So at the end of this line, so this is where you end up. This is what the final value of Venkat secret key. So you took Venkat, and then you encoded to UTF-8, and then you did SHA-1 hashing, and then you extracted 16 characters, and then you did the AES, and this is the output. This is the final output of that Venkat secret key movietickets.com. All right. So what is this? This is the symmetric key. This is the symmetric key, right? You see, if you go down here, right? So if you didn't understand the flow, right? Then if anybody were to look at it, the code, they simply go to main method. Yeah, this is main method. Oh, yeah, secret key is Venkat, secret key, movietickets.com. Gosh, let me copy it. Let me steal it. Wow, this is secret key. This is the symmetric key, right? I mean, symmetric key, right? So, let me take a picture. Let me go home. Let me use this key to break in, right? To decrypt all the credit card numbers being uploaded by the customers. But do you think if you steal this, do you think will it work? No, it will not work. It will not work. It will not work because they transform. They started out with some plain English, and they transformed at least 4 times. You see this? These many times it's like my same old analogy. It's like those blenders we talked about, right? So you have you use one grinder or blender to make a smoothie, right? You have banana and strawberry, apple, and you take it out, and you take out the smoothie, and again you put it in a different grinder, right? This grinder is more powerful, right? More smooth and soft and juicy, right? You put it in another grinder. Again, you run it. And then you get the soft smoothie again. Take that again. Again, put it in a different grinder. Powerful, commercial grade grinder. Run it again. Again, you get some even softer, right? Even softer smoothie. Again, take it. Put it in another powerful, supersonic speed grinder. Again, generate it. See, now between the first grinder and then the 4th or 5th grinder, right? Which one would you be able to figure out the taste or, by looking at it, right? Would you be able to tell whether the fruits were banana or apple or strawberry? It's hard. It's hard if you look at the 4th grinder. Maybe the first grinder, yeah, you can tell. Maybe you might see some apple, the pulp, maybe. Yeah, you may be able to figure it out, right? So the reason why I have to go to this 4 times, just to avoid that. I don't want hackers to guess what ingredients I have used in those grinders to generate that crappy string like this. You should not be able to deduce what fruits I have used in the beginning. So that's the intent, guys. Okay, why did I do that? Just to make it harder for any hacker to guess I don't want them to guess Venkat secret movietickets.com. Nope. To do that, I converted these many times. All right. See, so that's the intent. That's the idea of so now my key is not this. So my key is this, right? So now let's go back. See this guy, right? So this is where you got distracted, right? This is the magic. All the key conversion happens with this, and then you come down. So yeah, this is the typical. Now this is a URAES electronic code book, ECB. And then some padding, and then see here you're setting the program to in an encryption mode, right? Yeah, of course you are encrypting, right? So this is the encryption mode. See, your encryption. You're setting the program to encrypt using the secret key. So what is the secret key? The secret key is now this one, right? So this is the secret key. And it's not Venkat anymore. It's not Venkat secret key movie tick. No. That's not what it is. So even if you steal, I don't care. It's not gonna work. So this is the secret key now. We changed it. Where are we? Yeah. So here. So that's the secret key here. The transformed secret key. And this line, yeah, this is the one that encrypts. Yeah, encode to string, do final, and string to encrypt. So what is string to encrypt? That's your credit card, right? So this is string to encrypt is this credit card number. Remember your credit card number? this 2477, that's the credit card number. So if you are string to encrypt. You are taking that credit card number and then running it through do final with AES algorithm. And as you know, AES is symmetrical. So this will return, so that the output, the encrypted credit card number will be returned. Return means the calling program, right? So this will be returned. So you will be returned to here, because this is where you call, right? Encrypt method, this is where you call. So the program execution will come back here, and then the output you're assigning to encrypted string means this encrypted string will have the encrypted value of the credit card number. So that's it. So I'm printing here. See here, encrypted string, the same thing here, encrypted string, encrypted string. So system out print line. So it will simply print the encrypted string onto the when we run it, then you will see it on the console, right? So how it looks. All right. So that's how these companies, Amazon, LinkedIn, even your password, Google does the same thing. So they take your I'm sorry, not a password. I meant your credit card. So they are collecting your credit card number, and they are converting like this, and they are storing like this, right? So they now this converted string is what they will keep in their backend databases, and whenever you come back, for shopping, right? Next time future purchases, right? Or monthly recurring pay, I don't know, Google, if you have purchased the Google products, right? Google Business, Google Workspace, whatever, paid account, enterprise business account, so you have to pay every month, right? So every month, you don't need to open up your wallet and then punch in the credit card number. So they saved it, so they will extract, right? So this converted garbage encrypted string in their backend database server, they will retrieve. And then when they retrieve, it's a garbage string, right? So the string will be like this, right? Yeah, it's a garbage string. So they have to convert it. They have to convert that garbage string back to the real number, the numeric value, because they have to now charge a month later, and who knows the credit card is valid or not, right? Because credit card might have been expired, or maybe credit card may not have money. So that's why they have to validate. So in order to validate, again, they need to decrypt it. They need to decrypt it, and they need to see the number. And then again, they need to send your credit card number to your bank, whoever has issued the credit card. They will connect with the bank. Hey, bank, can you verify if this credit card is still good? And the bank says, oh, yeah, it's good, right? So then you're good, and then the transaction would go through fine, and then again, they will encrypt the credit card number back into the database. So this is a recurring process. So every time you come in, they will have to decrypt it, validate it, again, encrypt it back. I mean, they can either encrypt it back, or if they don't need to, because it's already encrypted, right? So they can pick and choose. It's up to them. All right, so that's the process. So now if you look at the decrypt, right, it's exactly the opposite process. What the code that we went through, the 4 levels of grinders and the transformation. So it's exactly the reverse. Yeah, of course, it's the same thing, right? So however you progressed, you just walk backwards in the same fashion, and then you will get to see the real credit card number. So, very quickly, let's go through this. So it's a decrypt method. So decrypt method takes encrypted string, all right? Not the clear string, but it takes the garbage string. And then, of course, in order to decrypt, you need the same secret key, isn't it? Because this is symmetric. Symmetric takes the same key. So I'm passing the same Venkat secret key movietickets.com to the decrypt method as well. right? See, so the decrypt, he's taking two parameters, encrypted string and then the secret key. So again, it's like calling. So you go back to the decrypt method. So there should be decrypt. See here the decrypt. And it takes the decrypted string, whatever, the encrypted string, right? Yeah, a string to decrypt. And then the secret. The same stuff. See, set key again. So the same 4 levels of transformation, right? We did it here. The red string here. Same transformation it has to go through. So yeah, so here, yeah, same set key. And then you set the AES method, AES. And now you have to set decrypt mode, right? So remember, if you remember, so here, the previous one is the encrypt mode. Now we are in a decrypt mode. So yeah, decrypt mode. Of course, you need to pass the same secret key, the transformed, right? The secret key. And then the return, yeah, it will see the string to decrypt. So this string will be decrypted with the do final and then will be returned. So yeah, you come back, you return here, and then the return string will be assigned to decrypted string, and then the same string I'm printing here. See here, decrypted string, same string, system print line. This is the print statement, so I'm printing it. Yeah, so this is the end of it. So at this stage, what I'm printing, 3. The original credit card number. So credit card number is same thing, right? So this guy, credit card number. This is as is, nothing changed. It's as original one, right? That's so 2467, right? That we printed. And then the encrypted string also I'm printing. Now you can expect here the garbage string, and then the decrypted string. So decrypted string should be same as the original credit card, right? So this and this should be the same. Only this guy is the garbage, right? So this is just the comparison purposes. I just kept it here. Original string, encrypted string, decrypted. Otherwise, original and decrypted should be equal. I mean, if you see if it is not equal, that means there is something wrong. We did it. The encryption did not do a good job, or we made a mistake somewhere, right? So this is the code. I mean, we will execute it. Yeah, of course, we will execute it and see in live. How it will work. Yeah, let's do it. Whatever, let's do it, and we'll come back. Yeah, this is the code, right? So this is the code. Let me copy this. Copy until this, right? So yeah, this is the program copy. So let me close this. Okay, so there is a online Java compiler, as you can see. Online Java can see gdoodle, so we can use this for our purpose. So yeah, this is any Java you can execute from here. Let me just. Yeah, see here, execute. If you execute it, yeah, see here. You see, it's print line, sum of x plus y. Yeah, so 10 plus 25, 35, right? See, it is printing 35. It's working fine. So let me delete this default program and then paste ours. See, this is our program, right? So our encryption, see, AES, and yeah, where is our main method? Yeah, so this is the main method, right? So when cut secret key, and this is the credit card number. Yeah, it is our program, right? So I'm printing these 3. So it will print 3 statements at the end. So let's execute it. Execute this program. Good. Yeah, so see here errors, errors, line number 19. Weird. Oh, I'm scrolling. Okay. So, yeah, 19, right? So 19 is right here. Yeah. So there are. This. Oh, what did I do here? My key.
I think it's just a comment. You can just comment it out.
Yeah, I think. Yeah, I can delete that. Okay. Right. So that extra line I have, some pseudocode I have written. So yeah, let me execute it again and see if that is gone. So now line number 40. Line number 40, line number 72, 73, 76, 77. 40 is what? Right here. Cipher. Oh, and this guy. Okay. That I believe hopefully that should be gone. Yeah, 40 is gone. Now 72, 76, 73. Oh, 72 is this. What's wrong here? Okay. The key is good. Okay. Okay. Yeah, so 73, I think. No, I think 73 is good. 76 is also. Let's execute it. Okay. Oh, 76 illegal character, right? Illegal character. Okay. Okay. Yeah, I think the yeah, the codes are not in a valid format. Okay. Oh. Yeah. Okay. Okay. Yeah, I think it should be good now. So let's execute it again. Execute it. Oh, again. What the heck? 76 again. 76. What's wrong here? Oh, I left an extra double quote. Okay, it should go now. Oh, good. So it did run. See, as you can see, that's what we're expecting, right? So original string, right? Original string is 2467, right? I mean, that's the original string, right? 24677. That's correct. Then encrypted string, as you can see, HU blah blah blah, right? Something crappy number, some gibberish, right? See here, this is the encrypted string, right? This is as a result of this statement. So this is the AES converted encrypted string, right? And then the last one is decrypted, of course, right? So the decrypted value 2466794 is same as the original one, right? So even the 64884, 64. So exactly the same thing. So that means it worked. It did work, right? So you took the original credit card number, you encrypted it like this, and you decrypted like this. So that's exactly what this Amazon and these companies are doing. You're giving them this original credit card number, and they're storing like this. They're storing in their databases like this, and whenever they need, they will decrypt it back to the original using AES, using the same key. AES. Right? See, AES. That's what you used. AES. Okay. So good. So this is this is called like engine, right? This is the real program. This is a hardcore program. I mean, if you recall, right, last week, there's online, we did punch in some strings, and then that site produced the key, the encrypted strings, the RSA, all these things, right? So that's a plug and play. I mean, that's not the code. That's what I told you, right? That's easy. I mean, anyone can go in and then you just type the string and then it will give you. But this is the real. It's like this is the core, right? Oh, this is the heart of your body, right? Yeah, without heart, I mean it's pumping in, right? So this is the engine. It's like for cars, this is the engine, right? The transmission engine. That's what it is. So this is the code that is what has to be written by those developers, right? Or security developers. They write it. So now, I mean, so this is all good. This is all good, right? Let me go back. Go back to when is that? Yeah. See, this is the program, right? Now you're a cybersecurity engineer. So are you happy with it? Is this good enough? Because remember, like going back to the step, your developer is asking you, hey, we are collecting data from our customers, and we are securing it, we are encrypting it, all that stuff, right? And then you ask them to give you the code, and they did it, and this is what you see, right? So now what do you say? What is your recommendation? Are you happy? Oh yeah, fantastic. This is good. I love it. Let me sign off. Go to production tomorrow. So what would you now say? I mean, guys, this is a real scenario. You will face this. This is exactly that you will be seeing when you get a job with your client. Nothing less than this. All right. So now you have analyzed the code. I mean, you run it through it, right? You validated it, right? I mean, we did, right? We validated it. We generated. We took the credit card number. We pumped it in, and then we generated the encrypted and decrypted both. We did it. So what do you think now? Do you see any problems, issues, concerns, comments to be improved? Anything? Are you super happy? What do you guys think? And here is the code. This is the magic code. Anything? Anything to say? Anything? Any